Hi, hello friends. Welcome back to my YouTube channel. Let's continue the importance of power system transmission. So, in the previous class, we discussed about the objectives of the power system. The first objective of the power system is to transfer the maximum amount of power with the minimum losses. Now, we will discuss the second objective here, and that is the voltage regulation of the transmission line must be zero. So what is the voltage regulation here? That is change in voltage from sending end to receiving end, okay, divided by receiving end voltage here, that is 0% here. So it should be 0%. Now we will see the importance of reactive power. So what is the importance of reactive power? The importance of reactive power, suppose if you take any electrical machine, suppose it may be a motor, or it may be a generator, or it may be a transformer. So in among all the machines, the common thing is the magnetic circuit. That means the energy conversion takes place in the medium of electromagnetic field only. For example, if we take any motor, when we give electrical energy to it, automatically the electrical energy getting converted to magnetic field, the magnetic flux, and the magnetic flux which is going to produce a torque. The torque will be mechanical energy here, like this. Now in case of generator also same thing. So if you give mechanical energy along with the excitation here, so it will flux links with the conductor changes, so there will be a EMF, that is nothing but the electrical energy. So in case of transformers also same thing. So in transformers, AC electrical will be given, and we'll get AC electrical only here, okay. Now there are three fundamental elements, which is nothing but inductor, capacitor, resistor. Now the energy is associated with inductor. Here we're talking about, now I'm talking about inductor. So in inductor, energy stored is half Li square. We know that energy is nothing but power into time here. So what about the energy consumed by a pure inductor? So here we're talking about active power, and here we're talking about reactive power. Now so P is equal to VI into cos phi. What is the cos phi here? Cos phi is nothing but we have taken 90 degrees. Why we have taken 90 degrees? Because if you see here, in an inductor, the voltage always leads the current by 90 degrees here. So here the voltage. So the angle between them is how much? It is 90 degrees. That's why we have taken 90 here. So cos 90 is nothing but 0 here. That means inductor is not going to take any power here. That's the conclusion. And similarly, what is the reactive power consumed by inductor? So Q is nothing but VI into sin phi. So here the angle which we are considering is in minus. Why? Because with respect to voltage, current is lagging. So here also we can take, so cos minus 90, so it is also be 0 only. So here if you take sin minus 90, so Q is going to be minus of VI. So minus here, okay. So this is about the inductor. And similarly we talk about the capacitor here. So here's the capacitor. The current leads, voltage lags here, okay. So current leads, voltage lags. Now here, because of this configuration, the current leading, so we'll take a plus 90 here. So P is equal to VI cos 90. Plus 90 means is the cos plus 90 or minus 90, both will be 0, and here Q will be positive. This is the energy associated with capacitor. So here I'm talking about capacitor. This is capacitor. Now the third important element of power system is, or circuits is, yes, it is resistor. Now in this resistor, the voltage and current phases both are in phase. So phi will be 0. So phi will be 0 means P is equal to VI into cos 0 means V into I only. Q will be 0. So reactive power consumed by resistor is 0. It won't consume any reactive power. And what about the active power consumed by resistor or inductor? It will be 0 here. So only the resistive element is going to consume the active power. So that's the point you need to remember here. So only resistor is going to consume the active power, okay. And for energy conversion from electrical to mechanical, in motors, and mechanical to electrical in generators, in electrical circuits to electrical in transformers, the magnetic domain, so magnetic domain medium is required, okay. So which is produced by the inductive coils consuming the reactive power. Similarly, Capacitor consumes reactive power by storing the electrical energy. Okay, and now electrical energy dissipated element resistor does not consume any reactive power. So this conclusions already we have seen earlier. Let's see the relationship between the Q and V, that is Q and reactive power and voltage. Now here we will take one generator, and here we have a load induction motor here almost, and a transformer here. So transformer and Vs at angle delta 1 and Vs at angle delta 2 transmission line, so JXL. So we have seen all these things in our previous class. Let's take Q1 is equal to reactive power demanded by the load. So reactive power required, so Q1 is the reactive power, and Q2 is the reactive power supplied by the source. So here we have Q2. Now what is the resultant here? So difference here, difference nothing but Q1 minus Q2 here. So we know that formula QR is equal to Vs VR by XL into cos delta 1 minus delta 2 minus VR square by XL. So here if delta 1 minus delta 2 is nothing but 0, difference is 0, so this will be maximum. So this is a QR, so this is a condition for maximum here. So Vs VR by XL minus VR square by XL. Now so we need to solve this equation, and we need to find the relationship between Q and V. So by using this, let us Vs x is equal to VR. So by solving this equation, so equation here, so x value we are getting it as Vs plus r square root of Vs square minus 4XL into QR by 2. So there are two possibles, one is a plus sign, another is a minus sign. So here we have a minus sign, and here we have a plus sign of this solution. Now here, so if QR is made 0, so if QR is made 0, so VR is equal to 0, which is not possible here. So this is not a valid case. Now so this is a valid one. So this is a valid formula. So this is a valid formula. Okay, now from this formula, so if QR is equal to 0, so QR is equal to 0 means Q1 is equal to Q2. So you can substitute the values. Why? Because if QR is 0, we discuss here one point that QR is 0 means Q1 is become to Q2 here. Okay, now if QR is greater than 0, so Q1 is greater than Q2, already we know. So suppose in the afternoon loads, in the afternoon, why? Because in the afternoon loads, almost all the loads are going to be on, okay, in offices, industries, everywhere. So that is the reason why the reactive power demand is more compared to supply. So sending end voltage is greater than that of receiving end voltage, general case. Okay, regulation will be positive difference. Now during the night conditions, or light load conditions, or Faraday effect, okay, during these conditions what will happen is the reactive power supplied, okay, is more compared to reactive power demand. Okay, so because of that reason, so QR is less than 0, QR is going to be negative, difference between Q1 and Q2, so it's going to be negative, and sending end voltage is lesser than that of sending end voltage is lesser than that of receiving end voltage. So we can call this a Faraday effect. Okay, so that's it friends for this session. We will continue in the next upcoming classes. Thank you. Thanks for watching my video. If you like my video, please subscribe, share and comment. Thank you.